So let's take a look at this situation where we want to figure out the end behavior of this polynomial. But it doesn't look quite like a polynomial. We don't have all the individual terms. It's been factored. Now I know I picked an easy one to start with here. Obviously you can multiply this thing out. And in fact that's what we're going to do. But I want to do this with an eye toward thinking about where the leading coefficient comes from. Right, so if we multiply this out, this will be 3x squared minus 9x plus x minus 3, which is 3x squared minus 8x plus 3. All right, now, where did the leading coefficient come from? All right, the leading coefficient is this one, and it came just from those two terms. It came from the first term in each of the factors, right? And now that we've got it in this form, we can tell. You remember how I like to think about this. If you put a really big positive number in there for x, this is a really huge positive number. And yeah, this number is negative, but as x gets large, it's going to be nowhere near as big as the positive number we're getting from the x squared term. So I would say this goes up to the right, right? It's getting really big and positive as the x numbers get bigger. And if we come over here to the left, if you put a negative number in there and a really big negative number, and you square it, it becomes positive. So ultimately, even when you're putting negative numbers in there, this first term is a really big positive number, so I would also say it goes up to the left. Okay, but really, I want you to focus on where that leading coefficient came from. It came from the first two terms of the factors. All right, so let's try this one. And this one, is a little different. There isn't a 1 there. There's a 2. There's an actual number that we write. So let's try this one more time. Let's multiply this out. I'm going to make this 2x plus 1 times 2x plus 1 times minus x minus 3. All right, so if we multiply this first part out, this is 4x squared plus 2x plus 2x plus 1, still times minus x minus 3. And we can combine terms here, right? This is 4x squared plus 4x plus 1 times minus x minus 3. And almost there, minus 4x cubed minus 4x squared minus x minus 12x squared minus 12x minus 3. And we combine our like terms, minus 4x cubed minus 16x squared minus 13x minus 3. Now let's back this up. Let's follow the trail backwards again. Right? This minus 4x cubed was there, and then it came from here and here. All right, notice that minus x was the leading coefficient, was the first term in that factor. Right, now let's keep going backwards, right? Where did the 4x squareds come from? The 4x squareds came, the 4x squared, there's only one of them, came from these two x's. So once again, right, look at where we end up. The leading coefficient came exclusively from the first or leading terms in the three individual factors. Right now, again, right, just to kind of finish out the question, if I put a really big positive number in here for x, that's and cube it, it's going to be positive. Multiply it by negative 4, and it's going to be negative, right? So this polynomial is going down to the right. And if I put a really big negative number in there and cube it, it's negative. Multiply it by negative 4, it's positive. So this one will be going up to the left. Okay, so what we're seeing here, and then the method I really wanted to kind of get across in this presentation, is that to answer the question of end behavior when the polynomial is factored, all you need to look at are the leading coefficients of the factors, right? Actually, the leading terms of the factors, right? Because we need the x's as well to get the final exponent. All right, so let's try this one out, right? And see if we, obviously, now we're in truly the case where I do not want to multiply this thing out. All right, so let's see what our leading terms are. It's this one, this one, this one, and this one. And remember, we also have to apply the exponents. So the leading term in the multiplied out version of this will be negative 3x to the third times 4x to the sixth minus 2x squared times 2x. All right, now remember, we really don't need to know the exact number of the leading coefficient. All I need to know is it positive or negative? All right, so let's think about what happens to the variables first. I'm going to get x to the third here, x to the sixth, x squared, and x. 3, 6. I'm adding up the exponents, right? X to the third times x to the sixth times x squared times x. You add the exponents together. This is x to the 12th. All right, and think about what's going on with the coefficients. All right, this one will stay negative. Positive 4 to the 6th power is positive. Negative 2 to the 2nd power is positive. And this 2 to the first stays positive. So in the end, my coefficient is going to be a negative number. I don't need to know what the number is. All I need to know is that it's negative. Right? Now I can answer the question of end behavior. If I put a really big positive number in there, raise it to the 12th power, it's still positive. Multiply it by a negative number, and it's negative. So this is going down to the right. If I put a really big negative number in there, raise it to the 12th power, it becomes positive. Multiply that by a negative number, it's negative. So it is also going down to the left. And that's how we can get the end behavior of a polynomial that's in factored form without going to possibly all the pain of multiplying the expression out. So this brings us to the end of our discussion of end behavior. And thinking in terms of the graph of a function, end behavior tells us what the function is doing at the edges, right? On the outside, if you will. What we're going to talk about it in the next section is something called multiplicity, and that's going to help us figure out what's going on in the middle, right, in the center part of the graph.